Hello students! So this is part 2 of factoring perfect square trinomials. In that last video we mainly just went over some basic details as far as like what a perfect square trinomial actually is, how to determine whether or not an expression is a perfect square trinomial, and we looked at the basic formula for factoring perfect square trinomials. In this video we're going to look at a few examples and we'll go from there. So let's say that we're looking at this example here. So in an example like this one, first thing that you'd want to do just to check it out to see if it's in the right form. So remember that we have to look at the leading term, which is 25y to the fourth, and the constant term first. So the leading term, 25y to the fourth. So the question is, can we write that so that it looks like this? Something squared. So can we do that? Is it a perfect square? When we were talking about difference of squares, we said that to get it written in this form as a perfect square, we said that you can take the square root of that number. So you can take the square root of that constant, the 25. So remember, the square root of 25 is 5, right? And we also said that to figure out exactly what that part is with the variable that goes in there, remember we said you can divide the exponent of that variable by 2. So what we see there is y to the fourth power, right? So if we divide that exponent by 2, that would be y to the second power. What that lets us know is that a is actually 5y squared. Okay, so we see that again a is 5y squared, and that came from looking at the leading term, 25y to the fourth. Next we look at the constant term. That constant term is 144. We can take the square root of that constant number to see if it will be a perfect square and if it can be written in this form. 144 can be written as 12 squared. B is 12. Now we need to check to see if that middle term, that quadratic term in the middle, we need to see if that is going to be equivalent to this middle part, 2ab. Alright, so let's check that out. Let's see if 2ab is the same thing as 60y squared. Let's write out this 2ab, and we'll substitute what we need to do there. We need to substitute and see if it winds up actually being the same thing, or see if it winds up being equivalent to 60y squared, right? So let's do that. So that is 2 times the a, which is, what did we say a was? 5y squared. So that's 2 times 5y squared times the b, which is 12. What if we rearrange it? Not that we have to rearrange it, but again, remember, you multiply all of the constants together. 2 times 5, which is 10, times 12, right? So that's 2 times 5 times 12. That's 10 times 12, which is 120. Y squared. Okay. Alright, so guys, you see here, what we've got for 2ab does not match up with that middle part. So when we were asking, is it in this form? In other words, is it a perfect square trinomial? No, it's not a perfect square trinomial, because that middle part, the 60y squared, doesn't match up with the 2ab. Doesn't match up with what we got for 2ab. So again, that means that it is not a perfect square trinomial, because again, it is not in the right form. 2ab equals 120y squared, which is definitely not equal to 60y squared. So again, it is not in the right form, folks. Again, since that original polynomial, 25y to the fourth plus 60y squared plus 144, is technically not in the perfect square trinomial form, that a squared plus 2ab plus b squared form, then it is not a perfect square trinomial, and we cannot use the formula for perfect square trinomial. We can't factor it as a perfect square trinomial. Okay, so let's say, as for another example, we were asked to factor 64x to the sixth power minus 160x to the third power plus 100. So let's make sure that we've got the right parts here. So let's make sure that the 64x to the sixth power, let's make sure that that's a perfect square. What squared gives us that? And remember, we can take the square root of that number, the constant coefficient there, and square root of 64 is 8. And of course we can divide the exponent there by 2. That would make that be x to the third power. Alright, so if that is the case, okay, it's a perfect square. This part of it is, and so that means that a is equal to 8x to the third power. Alright, the next part, we look at the constant term here, 100. Alright, so 100, it can be written, of course, as something squared. We take the square root of that, take the square root of 100, and we know that square root of 100 is 10. Okay. Gotta love it when your phone rings while you're doing a lesson video. Haha. Alright, so we see there that again, the square root of 100 is 10. That means that b must be equal to 10. Okay, so now let's make sure that that our middle term is the same thing as 2ab. Alright, so let's do that. 2 times a times b. Alright, so 2 times 8x to the third times 10. Okay, so far the x to the third part matches. So notice here how this middle term here, the one that's supposed to be equivalent to 2ab, notice how that's a negative. So you need to kind of be aware of the fact that that is a negative 160, which means that we have to consider, even if these numbers here, the 2 times the 8 and times 10, 2 times 8 gives you 16, 16 times 10 gives you positive 160. Okay, so what we need is negative 160, which means that we have to consider the fact that maybe b is not positive 10. just maybe, and more than likely, B is negative 10. Okay, because that is actually more likely. It's more likely that B is negative 10 than it is for B to be positive 10. Because when you square negative 10, you still get positive 100. Okay, so B is actually negative 10. Alright, and that makes that actually correct now. Okay. So now that we know that B equals negative 10, that is correct now. Alright, so this gives us negative 160x to the third. Alright, and so our middle term is negative 160x to the third, and that's what we want it to be. Okay, so 2ab is equivalent to our negative 160x to the third. So this is in the right form. It is definitely in the right form. It's in that perfect square trinomial form. So we need to use our formula. And what I neglected to mention before is that there are two versions of this formula. In our last video, part 1, I only showed you one version of the formula. I'm going to show you both versions of the formula here. Again, folks, there are two versions of this formula. One of them is where you have a plus b squared as the factors, and the other one is where you have a minus b as a minus b squared as the factors. And so again, for this one, it should be pretty clear as to which version of this formula we're going to use, because we can see here that this part here was negative 160x to the third, and that 2ab was a negative. Yeah, and so that should be kind of clear as far as that is concerned. So what that means is that if we use that formula, that means that 64x to the 6th power minus 160 x to the third plus 100 that should be equal to a minus b squared. And again, we already identified what a and b were. So again, that's 8x to the third, and b is 10. And remember, I'd asked us to kind of consider the fact that that this was negative 10, and that was the reason why. Okay. Okay, that is it there. That is the answer, our two factors. Alright, so we have factored this thing here. I hope this has been helpful to you guys, and that's it. You guys may have to look back at your factoring difference of squares video. Ooh, that is so sloppy. Y'all, excuse me. You guys may have to look back at that video to help you do part of the Khan Academy assignment. Alrighty. That's really it now. Bye.